So up till now we have worked with classes, simple classes, abstract classes, classes extending another classes and things like that. But in this video we will talk about a new thing, interface. What is an interface? So before Java 8, interface used to be a contract, used to be a hard contract, I might say. What does it mean? So in case of, we know that in case of an abstract class can have abstract and non-abstract methods. So if an abstract class has certain abstract methods, then any class that inherits that abstract class will have to provide the implementation of all the abstract methods. That is the condition. But the good thing is an abstract class can have non-abstract methods. So methods with body. That is the thing with abstract classes. But in case of interfaces, before Java 8, interfaces used to be 100% abstract. That means it was not possible to provide or to write a method with some body in interfaces. All the methods defined in the interfaces used to be 100% abstract. So it was like a contract, for example. So if we defined a type runnable, which is actually an existing Java class in the JDK system that is used to run the threads. So for example, if there is an interface runnable and it has two methods, run and stop. So before Java 8, the condition was these two methods will be abstract methods, and any class that is implementing the runnable will have to provide the implementation. So interface is a way to define a contract that a type would behave in this way, but we don't know the actual implementation, but we don't know the actual behavior. It is the responsibility of the implementing class. So let's see this in action. Here we have a new package interfaces, and I have created a new class interface runner to run the demos. Nothing special. Now let's create a new interface. So interface, let's name it my interface. Okay, so if you notice the difference between a class and an interface, then it has the access modifier. It has the name same as the class, access modifier, and name of the class. But the difference is, to create a class we use the keyword class, but to create an interface we use the keyword interface. So here we have a very small, very simple interface, my interface, and this interface is doing nothing. It's empty. Now, how do we use it? How do we implement, or because in case of classes, we extend from the classes, but how do we use interfaces? So let's create a new class, my class, and we will see how to link the class and the new interface that we created. Okay. So whenever we are trying to implement an interface, we don't use the keyword extends, but there is a new keyword implements that is used to implement the methods of an interface. So this means that we are creating a new class, and this class will implement the my interface. But in this case, because there are no methods, so this is perfectly fine. Now, how do we create the object of this class? So this is pretty simple, same as the inheritance. We can say my class equals to new my class. That is also valid, or we can say my interface a equals to new my class. But we cannot instantiate interface directly, so we cannot say something like this. This is not valid. We can not instantiate, we can never create the instance of an interface directly. So this is not valid. We always create the object of the class that is implementing this interface. So these two are valid declarations. Now let's keep only one and move on. So what can we do? What can we put in this interface? First of all, let's talk about variables. Can we define variables in an interface? Yes. So let's say we declare a variable int and let's emit value. That's it. Now, what is this error? So if we mouse over, it says that variable value might not have been initialized. So in case of interface, all the variables that we define in the interface, they are by default public, static, and final. And the final variables must be initialized when we are declaring them. So that's why we are getting this error in the interface. But if we define or if we declare something similar in the class, then it's fine. Because the variables that we declare in the class are not by default static and final. So this is fine with classes, but not with interfaces. So we have to provide a value. So let's say we do this 12. Now let's write a simple dummy method, and if we do something like, so we can access the value variable because we are implementing the interface, so we can access the variable that is defined in the interface. But if we try to change it, let's say we try to change the value, then it won't work. Let's see the error. It says cannot assign a value to final variable. So what are final variables? So we will cover the final variables separately, but in short, public static final variables are treated as constants in Java. So this means any variable that you declare in the interface, they are constant variables and we cannot change constants once initialized. So that's why any variable that is declared in the interface, we cannot change the value in the implementing class. So this is not allowed. And as I said, by default, they are public static final. So even if we are writing, uh, declaring the variable in this way, just the data type and the value, but by default, the compiler treats this declaration same as public static final int value equals to 12. So this is what compiler will be doing under the hood in the background. So if we write same thing explicitly public static final, then also it's fine. But because the variables are by default constants in case of interfaces, so we can omit these details. It is redundant, but they are still public static and final. So that's on the variables in the interface. Now let's move on. What can we do? So we can create some methods in the interfaces, and we know that before Java 8 they used to be 100% abstract. It means we can put abstract methods in the interfaces, and the class that is implementing the interface will have to provide the implementation. So let's define a simple method, do something. And we know that the abstract methods don't have the body, so they end with semicolon, not with curly braces. Now, same as variables, all the methods by default, all the methods are public and abstract. So if you notice, we did not provide the access modifier and we did not use the keyword abstract. In case of interfaces, these keywords are by default applied to the methods that we declare. So same as variable, compiler under the hood, the compiler will do something like this: public and abstract. It will add modify these keywords automatically, so we don't have to do it explicitly. We can simply omit public and abstract, but they are still public and abstract. We just don't write it explicitly. So this is an abstract method, do something. Now the condition is any class, any class that is implementing the interface will have to implement the method. This will not compile, it will have to implement the method. So we need to give the implementation of do something method, and let's print a message and run the code. So we can say a dot do something. So here we created an abstract method in the interface, and it has to be implemented in the implementing class, and we see the message on the console. So this is a very basic setup, very simple setup with interfaces. Now let's move on. So we said that before Java 8, interfaces used to be 100% abstract. It means all the methods in the interfaces used to be 100% abstract, same as this one. So the problem is, for example, if you consider this setup, this interface has a single abstract method, and this my class is implementing the interface, and everything is working fine. But consider the scenario where we have to modify the my interface. We have to evolve my interface. So if we have to, for any requirement, for any future requirement, let's say we some to do something, we modified this interface and we added a new method, do work. Now as soon as we do this, we see a warning in the implementing class. And warning in the implementing class is that this class is implementing this interface, so it must give the implementation of all the abstract methods, and it is doing that for do something, but do work, the new method, it's not there in the implementing class. So that's the problem with the interfaces, the evolution. So if we are evolving the interfaces, if we are adding new methods in the interfaces, then as soon as we add a new method, it will break all the existing classes, all the classes implementing the same interface, because the new method is not there. So it's a huge effort to modify all those classes, to to recompile them and ship the new version of the code just because we added a new method in the interface. All right. So to solve this in Java 8, in Java 8 to solve it, Oracle came up with a new solution that the interfaces can have static and default methods, and these are methods that can have some body, same as abstract classes. So the default and static methods can have a method body, can have some implementation in the interface. So any class that is implementing that interface now has a choice to use the default implementation or override the method, same as the inheritance and classes. So let's see that. Let's add a static method and let's see how it works. So to create a static method in the interface, we use the keyword static, then the return type. So let's say the return type is void simple, and name of the method do work. But this time we cannot put the semicolon here because this is not abstract. This is still public by default because compiler will add the public keyword, so we don't have to do this. But this is not abstract anymore, so we have to provide the body. Now let's say we say parent static. So you see, with the help of static method, we added a new method in the interface, but this is not breaking the child anymore. And now if we try to access the do work, then we cannot. But the thing is, if we try to access the do work method, we cannot access it in this way. To do that, we have to use the interface name. So my interface dot do work, that is allowed. Or in the do something, we can access the interface's static method like this. So if we run the program, we see the child and parent and static. So in this way, we can define the static methods, and we can use the static method using interface's name. But the static methods cannot be overridden. We cannot override the do work method. What we can do, maybe we can write a same method, public void do work, do something else. This is allowed, but this is not overriding. This is simply shadowing the static method. Okay, so we cannot override static methods. Now let's use the default. So interfaces can have default methods as well, and default methods can be overridden. If we add a default method, and let's name it log, for example, parent log. So this is a default method, and default methods can be overridden. So here, for example, in the class, it will not, if we add a new default method, same as static method, it will not break the child, and the child has a choice to use the default implementation from the interface or to override this one. But for example, we don't override the method in the my class, but if we try to access it, this time we can do it because these are default methods. Static methods are not accessible via the reference variable of the class, but default methods are. So we can say a.log, and if we run, we see the parent log. And we said we can override the default methods in the implementing class. So we can do that. We can say public, and you see the ID is giving me suggestions. So I will simply hit it, and we will override the log method. And if now we run the same program, we see that the child is actually calling the overridden method, and that's why we see child and log, basically this message on the console. So that's how we write a static method, a default method, and that's how we override a default method in interfaces. Now moving on to how do we, same as classes, what if we have to call the parents method? So in with classes, we used to use the super keyword, and we used to do something like super dot parent method. But if you see, this is not allowed in case the class is implementing an interface. This is an error, and we don't see any suggestion. We don't see any suggestion related to log or do work. So how do we do that? In case of interfaces, we have to tell that, okay, we have to access the super of interface. So there is a special syntax to do that. So we write the name of the interface. So my interface, then dot super, and now we can call the method from the um, interface. So for example, log. So we are overriding the log method, but we want to call the interface's log method first before we do something else. Now, if we run the same program, we see parents log, which executed first because of this line, my interface.super.log, and then we see the child log, which is basically the implementation given in the child. All right. So we have covered quite a few things on interfaces, and there is one more thing to cover: the private methods in interfaces. Private methods, earlier, I think after Java, starting from Java 8, it was possible to add default and static methods in interfaces, but not the private methods. They were added, I guess, in JDK 11 or JDK 15, I cannot recall. But because I am using JDK 19, so I can use the private methods. So please make sure the Java version that you are using, and please read the specification. But in Java 19, at least in Java 19 and JDK 17, we can write the private methods in the interfaces. So interfaces can have any private method. So public void, for example, clear. This is a private method, and we can, so the thing is, this is to avoid duplicate. So anything that we are duplicating in static and default methods in interface, we can extract that duplicate code and put it in some private methods basically. So that's the simplest use case of private methods, and we can call the private methods from default and static methods. Okay, so here you see we cannot do that because we cannot access non-static methods from the static methods. So it has to be private static if we want to call this method from the static method. Otherwise, simply remove it from here and put it in the log. Okay, so same as private, we can have private static methods because interfaces can support two variant actually, static methods and default methods. So similarly, there are two variants of private methods as well. Okay, so let's uh, keep it there and move on. So I am creating a new interface, interface one, and I am simply writing or declaring one abstract method work. Now let's create another interface, interface 2, and let's create the same abstract method in interface 2 as well. Now create a new class. Let's call it demo, and this class will implement both the interfaces, so interface 1 and interface 2. Now, a class can implement as many interfaces as it wants. So there is no restriction. We can implement both the interfaces. So we see because this class is implementing interface 1 and interface 2, and any class that is implementing the interface, it has to provide the implementation. It has to implement the method defined in the interfaces. But the problem here is the method looks duplicate. In fact, it is duplicate. So interfaces have duplicate methods work. So which method should it implement in the class? And how does it identify which interface, the method that we implemented, to which interface it belongs? Actually, there is no such conflict in case of interfaces. So interface is simply a contract that you should have a work method. And as long as we have a work method, it will satisfy both the interfaces. So there is no such conflict. If we are if we are implementing the work method, it will satisfy interface 1 and interface 2 at the same time. So we can solve this problem by simply providing an implementation, by simply implementing the work method. And it will work for interface 1 and interface 2. So that's perfectly fine. Let me just remove it and let's create a new object of the demo class. Okay, now let's change it. Let's say we have default method now, and we have a println that interface 1. What happens now? So now we see it has actually an error that it says that either must be declared abstract or implement abstract method work. So even though it is overriding, even though it is actually it has the access to this work method from interface 1, still we see that it is saying to extend uh, as to implement to provide an implementation of the work class. So there is some conflict now. Now let's add, let's make it default as well. Now what happens? So we have two work methods, two default methods in interface 1 and interface 2, and this class is implementing both the interfaces. Now which version of work would it override? So there is no way to tell. There is this conflict which is also called the diamond problem, diamond of death. So this class is actually implementing two interfaces and they have the similar implementation. So the Java compiler has no way to identify which version of the method would you be getting access to. So you need to tell the compiler explicitly. In this case, to resolve the conflict, let's implement the method first, and now it's up to us which version do we want to use. So if we want to use the interface 1 version, in that case we have to call interface1.super.work, or if we want to use the interface 2 method, then we would need something like this. So the point is, if we have such a conflict, then the only solution to resolve that conflict is to override the method in the class and call the method from the interface explicitly. Java compiler or runtime won't be able to resolve the conflict automatically. So that should be all on the interfaces. We covered the basics and default and static methods, how to use the super keyword, and how to avoid such conflicts. Thank you.